Good day, students and viewers. You are welcome to the studios of Maths X. In our previous video, we were on the part 1 of properties of sets. In that video, we talked about the cumulative and associative properties of sets. And we backed it up with explanations, examples, and Venn diagram descriptions of these properties of sets. In today's class, we are going to go into more properties of sets with the same things, explanations, examples, and Venn diagrams to back up your understanding of properties of sets. But before we start our class today, we urge you, my dear students and viewers, to like and share our videos. Do not just watch it, like and share our videos. As you do so, you give us a lot of value. Let us begin our class today. Thank you. Let's go for the third law or the third property of sets. I'll take off that part of the board. The third law is the distributive law. The distributive property of sets, can call it law, there's no problem with that. That states that A union B intersection C is the same as A union B intersection A union C. That's what we have there. This is for its union. The example of this one will take some space, so do bear with me. Let's start with B union C, B intersection C. We've done this before. B intersection C is the set 2. Is a set 2. Now let's talk about A union B intersection C. This will be our A, which is 1, 2, 3, and 4. All right. Then union B intersection C, we had that as 2. So our final answer of this clearly will be again 1, 2, 3, 4. Since it's a union, remember, no repetitions. Please do mark this particular answer. I'll asterisk it. Now let us work on A union B intersection B union C and see if the answer corresponds to this. For our A union B, let's start with A union B. Our A union B is going to be a set 1, 2, 3, 4, 6, and 8. This is our A union B. Let us work on our A union C. For our A union C, will be a set 1, 2, 3, 4, 5, 7. This is our A union C. Let's work on A union B intersection A union C and see if it gives us the same answer as we had here. So for our A union B intersection A union C, let's check for what is common. Clearly, I can see that 1 is common in the 2. 2 is also common. 3 is common, as 4 is common. So if you check up these two, they have the same answers, meaning that truly our A in the distributive law for its union, that A union B intersection C is the same as A union B intersection A union C. This is what we have here. Let us put forward the Venn diagram description of the union of the distributive law. So it will look like this. It's very simple. 3 subsets. We have subsets A, B, and C. the universal set mu. All right. So our B intersection C is here. First of all, cut that one. Then of course, union what? A. So this is it. This is the region that describes the union of the distributive law. From here, let us move to the intersection of the distributive law. For the intersection, rather, of the distributive law, the expression is like this. A intersection B union C. This is equal to A intersection B union A intersection C. Let's begin to compare the two sides. We know that our set A, let's work on B union C first of all. We know that for our B union C, we know that our set B is 2, 4, 6, and 8. It has elements 2, 4, 6, and 8. Its union with our set C is 2, 3, 5, and 7. That's it. So their union will yield a set that is 2, 3, 4, 5, 6, 7, and 8. Those are the elements of B union C. I just put that forward there. Let us look at also A intersection B union C, which this is B union C. So for our set A had elements 1, 2, 3, and 4. That's what we have. Then intersection of what we had here, which is 2, 3, 4, 5, 6, 7, and 8. All right. Our intersection for our set operations, our video on set operations, I had explained what intersection is, what is common to the two sets. All right, for what is common to the two sets, I have here, first of all, a 2, a 3, and lastly, a 4. As you can see, there's no 1 here. So that is our A intersection B union C. Now, let's look at this other side also, A intersection B union A intersection C. What would that give us? So first of all, let's start with our A intersection B. Our set A, we know, has elements 1, 2, 3, and 4. Intersection, our set B is 2, 4, 6, and 8. So what is their intersection? As you can see, 2 is common, 4 is common. So A intersection B has elements 2, 4. That's what it is. Let's look at A intersection C. For our A intersection C, we're talking about, again, 1, 2, 3, and 4. Then intersection C, our C is 2, 3, 5, and 7. What is their intersection? Rather, their intersection clearly will be a 2, a 3, a 2, and a 3. That's what we have here. That is their intersection. So 2 and 3, that's 2 and 3. Let's close it down. Then, having done this, our A intersection B union A intersection C. This is our A intersection B, and this is our A intersection C. So let's look at it. What we have here, what is common? 2 is common, 3 also is common, and a 4. So if you look at this and look at this, they are the same. So clearly, what I just did here is very, very true. Having done this, let us also put forward the Venn diagram description of the intersection of the distributive law. The Venn diagram description of the intersection of the distributive law will look like this. Let's start with our subsets. Okay, that is my A, my B, and my C. That's my mother set, or the universal set. Pardon me for saying that. Now, our Venn diagram description will look like this. First of all, B union C. This is our B union C. This is the region that satisfies B union C, the whole of this. All right. But it in which part of it intersects with A. All right. So to have that, it means that the region that satisfies this will be here. We need to be careful now before we put in the wrong places. So this is Venn diagram description for intersection of the distributive law. I need to state something, my dear students and viewers. Many times, the distributive law is, some students do find it a bit difficult to express, but it's very simple. Look at this expression like this. So if I have A times B plus C, how would you express this? Very simply, it will be A times B plus A times C. Please look at it like this, for both its union and its intersection. So you just make an expansion of it. So if you check out based on this, so this is going to be your A times B plus my A times C. That's what I'm having here. That is the distributive law. It's pretty simple to expand, because I've had some calls from students telling me that the expansion is a bit confusing, and I would not really agree with that, my dear students and viewers. Just look at it like this. My dear students and viewers, this is as far as we go in this video. If you have any questions or issues about the lesson we've just learned, do send us a comment or a chat. We'll be more than willing to attend to you. Until then, keep watching the videos of Maths X, like, share, and subscribe. As you do so, God bless.